Online invigilator was also disturbing. You come this side. The camera is capturing. Wait, let's discuss with most of the students because this is Kavya. Kavya. Can I give sample papers? You come here, you sit here, you practice. I will hand it because new batch with them also you can start. Kavya, hi beta. How are you? Everyone ready? Himanshu, hi. Are we all ready for science revision? So beta, can you give me the dates when and all you people are available and how and all I have to start preparing you all? So 21, good evening. 21, ma'am, is set 3 easy? Yes, set 3 was little easy compared to that of the other sets. Set 2 was lengthy. That's no short. See, set 2 was. Himanshu, कैसा किया बेटा? Set 3, set 1, set 2. Which set came for you? हाँ? हाँ. But set 1 was okay. Set 1 was easy. See, mostly question papers may not have that much variations. Okay. And beta, one best quality was there. Kritika, how you wrote beta? Set 1 was yours. Now listen, a full year what I taught, presentation was same type question paper. Correct now? This year I am going to do only one work. From the beginning, the videos what I am making now, will make a playlist and last moment will run that playlist. It will be very helpful for other students. Good, you wrote Kritika, good only now. See, last moment yesterday, similar triangle, anyone who might have joined that question, they might have seen that question what I gave. Yesterday, both were talking. I shouted on you and I told this type question is coming in exam. And seriously, that question came. Correct, na? 2:3 ratio. Huh? Same question came yesterday, na? Similar triangle question which nobody was able to solve. That similar triangle question came today. Yesterday only I discussed. Vishwa, good evening. Kavya, good evening. Everybody, good evening. Chalo, are you all now going to listen me for science? That we have to do science very better. Science preparation, for science preparation, are you all ready? Tomorrow don't go school anywhere. Listen children, tomorrow don't go anywhere. School to everything. Yes? Yes. Yeah, we got the screenshot of the papers. See, if I want, I can discuss some of the questions of this paper, but most of the questions, this type question we discussed in class. This type questions we discussed in class. Fully we discussed this type questions. I don't know what happened, but most of the questions we had discussed in class. And that's why today I took the screenshot of your questions and then said, huh? Composite number questions came. This pattern question we studied in class. And every pattern questions came. Yes, shall we start? Now look here. Fresh revision we are going to start, children. Case study, I was always shouting on you people and telling case study, case study. Okay, now listen. Elevation, everyone. Now I think you people see. First we will make one strategy and we will follow the strategy. Okay, our strategy is today is what date? 17. Next, when is examination? 21. So 21. So you have 18, 19, 20. So which day, 2 days can you prepare for English? Or you want all these 3 days for preparation? I have no problem. I can explain whatever chapters you will be telling. I will be explaining the chapters. I will be discussing that part. So at least 2 days are enough for English or not? So tomorrow full day can I teach? Yeah, but I will start after 11 o'clock. 11 o'clock is the line, 11 o'clock till night. But you people don't get saturated because always you are telling that that's it, that's it. I am teaching, you people are telling don't. Okay? Ma'am, English एक ही क्या होगी? Okay. And after that 21, after 21, After that 23, what exam is there? AI is 23. After that, when is science? Science. Science is at 27. Every interval we are going to utilize. Listen. Everyone, every interval we are going to utilize. One time, please check. So tomorrow and today we are going to, yes, elevation. Everybody, just listen right now. We are going to start magnetism now. I will be explaining magnetism from zero level. First, I'll start from that only. 23 you are having? Second language, Hindi you are having, na? And then Hindi is having when? 2nd March. After science exam only, na? Then science is which date? 25 is science. So only 25. So we have only this much limited time. Okay. Night I'm going to utilize. Now quickly I'm going to start magnetism. Please kindly get ready for magnetism. Some of the important concepts of magnetism first I'm going to explain. Chalo, get ready please. Everyone. Boys. Yes. See, some of the important properties of magnetism I'm going to start. Everybody please get ready. One time I will be explaining magnetism. Then I will be giving questions related to magnetism, MCQs questions. Wait, I will send some questions to ma'am because I shortlisted some questions. So now please start doing the work. Till then we will be starting. Okay. So today non-stop work we are going to do till 11 o'clock night. Are you people happy to be with me? One by one, chapter by chapter. Okay, Satya, everybody, please understand. Today you wrote one examination, that is an eye opener. I hope you people have now understood what level questions can come in examination. So please, children, listen me. Between magnetism explanation, after that, I will give you heredity MCQ question test. Okay, heredity MCQ question test we will do one by one. We will follow the part. So are you all ready? Please. Now, first I'm explaining, just give me 1 minute. So what is exactly magnetic lines of forces? Everybody, please start with this. Magnetic lines of forces. What is the meaning of magnetic lines of forces? Everyone, please say me, what is the meaning of magnetic lines of forces? If anybody will ask you, magnetic lines of forces, what is the meaning of magnetic lines of forces? Magnetic lines of forces. Chalo, start doing it. Magnetic lines of forces. What is magnetic lines of forces? I have to send some pages to ma'am. Namasvi, the amount of force that magnet exert. No. Yes, that's Yashwit, but answer is not that level. Satisfaction is not there. No, not satisfied. Please, anyone else say the answer. Magnetic lines of forces. Anyone else? Inform in the group, first class started. What is the meaning of magnetic lines of forces? वेरी गुड हिमांशु, लास्ट टाइम तुमने भी अच्छा आंसर्स दिया था, इस बार भी आंसर देने का कोशिश करो. मैम को ये क्वेश्चंस भेजना पड़ेगा. Okay, so what is the meaning of magnetic lines of forces? Imaginary lines of magnet which shows the magnetism. No, that is also, that's more, far more. इससे पहले वाला ही आंसर तुम्हारा अच्छा था. Magnetic lines of forces. चलो शुरू करो तुम लोग, मैं भी शुरू होती हूँ. Ready? Imaginary lines. Fine. चलो शुरू करते हैं. So somebody will be asking you about magnet. We are going to start. So these questions they will ever ask. Magnet will have two poles. One will be exactly north pole, another one will be considered as south pole. So very specific point and lines first we are going to discuss about magnet. Now one by one we are going to discuss. So a magnet is a material which can attract substances like iron, nickel, cobalt and steel. So basic questions we will be expecting. Please everybody remember one thing, what type of questions we are going to expect in board examination. You will be expecting questions which is very much grounded. They will ask you mental questions, they will not ask you the typical questions. See, basic part you have to be very good in. So what type of material magnet is attracted to? So some of the materials are iron, nickel, cobalt and steel. So this is the question which we can expect: iron, nickel, cobalt, steel. Understood not? So they will give. See, steel also will be getting attracted towards magnet. So many times people will think that steel will not get attracted towards magnet, and there only they will do mistake. Understood? So basic line by line information is important. So now a magnet has how many poles? Two poles, north pole and south pole. So when suspended freely, it will head towards north and geographical north and south. Okay. So when broken into pieces, every piece of magnet will represent a new magnet. But every piece of magnet, correct only, the density of these lines indicate field intensity. Absolutely correct. But I want to answer some of the questions. So please kindly listen very carefully. So whenever we talk about magnet, understand one thing, every piece of magnet you are breaking from one magnet will have magnetic field lines. But these magnetic field lines intensity will vary. Are you understanding? The intensity of smaller magnet will be weaker in compared to that of the intensity of a bigger magnet. Yes, the force of attraction will also be less. Magnetic field line will also be less. So there are certain things we must remember. So now what is the meaning of magnetic field? Understood? The region around a magnet where it influences felt by any other magnet element is known as magnetic field. So its influence is experienced. Its influence is exactly experienced. So every other thing which is having an influence on this magnet will be exactly experiencing this magnetic field. Like if I will keep any iron object, if I will keep any steel object, if I keep any cobalt object, at that time you will be seeing that they will experience what? Magnetic field. Understood? So they will either be attracted or they will be repelled. I hope you might have understood. So some will be attracted, some will be repelled. So that's what. So magnetic field, the region around a magnet where its influence is felt by any other magnetic element. So that will be called as magnetic field. Now, Yashvi, check this one out. Magnetic field lines. Magnetic field lines are not imaginary. Okay, they are actually the field. Understood? So magnetic field lines come out of north pole of a magnet externally and get into the south pole, forming closed loop. Understood? They are invisible, but yet they exist because they have the tendency. Then good evening beta, how you wrote examination? So they have tendency to repel or attract, and that repulsion or attraction is visible. Are you understanding? So yes, that attraction or repulsion is visible now. So if near a magnet, you will keep near a magnet, if you will keep any nail, what the nail will do? The nail will go and stick with the magnet. So that attraction or repulsion is a visible cause. The lines are not visible, but its effect is visible. Understood or not? So this is very good, beta. So magnetic field line come out of north pole and it is going towards south pole. Now magnetic field lines are closest at the pole where the magnetic field strength is maximum. One by one we will discuss. No two magnet field line intersect each other. They'll never intersect. The direction of magnetic field at a point is indicated by tangent to that point. This is the most important point, and this is the hitting point. Again and again I am going to explain about magnetic field lines. So one by one we will discuss about magnetic field line. The first thing about magnetic field lines, the field line come out of north pole. So whenever we talk about a magnet, the magnetic field line will come from north pole, goes towards south pole. This is first part. The magnetic field lines will be, they see right now only I told don't write the word imaginary. Imaginary is not taken because they show effect better. Invisible but impactful, because the magnetic field lines are existing and they have impact on those materials which show its properties in presence of magnet. It is showing now. So that is what invisible lines. Very good. Coming from north pole towards south pole. I hope you might have understood. Now beta, some of the criteria we are going to first understand about magnet. Okay, because now it's the final phase, so we will not see day and night. Now please today at least cooperate. After maths examination, you people have understood. So can we? Yes, it is invisible lines. Now look here beta. First is कि whenever we talk about a small magnet, every magnet is having its magnetic field around it. Understood? Now, this magnetic field is generated because of the magnetic lines. Understood? So, these magnetic lines are generating a field called as magnetic field. Understood? So, these magnetic lines are generating a field called as magnetic field. Now, the strength of this field depends upon the magnet. Understood? If it is a very strong magnet, its magnetic field intensity will be very, very high. How to come to know that its magnetic field intensity is high? What will explain its magnetic field intensity? This is exactly the intensity. Understood? They will have very near loops. The loops generated will be very, very near, and the loops will be more in number. Understood? That means the magnet is having a very strong magnetic field. Did you understood this one? The magnet is what type magnet? Strong magnet having a strong magnetic field. Understood? But here, if I will compare with another magnet having only little lines of forces, that means what? Which one is the stronger here? Understood or not? So this one is stronger and this one is weaker. How? Because here the loops are very, very close and dense. So here the loops are dense, close. I'm talking about the loops, closed loops. The loops are dense, close, and more in number. That means the magnet is a strong magnet. Did you understood it? So if any experimental question they will ask, you will be able to answer this question. Understood or not? Now beta, the first property you understood. How we will compare the magnet? We will say that two magnets are there. The magnet which is a very strong magnet will have more loops, closed loops. Understood? And closed parallel loops will be there, and see parallel inside. Got it? So closed loops will be there, more in number. So they will be very, very dense. They are very, very close and more in number. That means magnet is a strong magnet. So where the magnetic field strength will be maximum, where we will experience a strong field of magnetism. So we will be experiencing a strong field near the loops. Understood not? So near the pole. North pole and south pole, because all the loops are coming out from there and going inside. So since the loops are exactly coming, so near the poles you will experience a very high number of magnetic field lines. So the strength is maximum near the poles. The magnetic field strength is maximum where? Near the poles. Another area where you will feel or experience strong magnetic field, that is inside the magnet. What happens inside the magnet? All the lines of forces inside the magnet stays parallel. They never intersect each other. They are very concentric, and you will be seeing that a very strong lines, parallel lines will be present inside. They are never intersecting. These parallel lines align themselves and come out as loops. Did you understood this part, beta? Huh? So they will be parallel inside. So the magnetic field strength will be uniform inside. Is it uniform? Yes. You see the lines will be parallel, equally distributed inside the magnet. Did you understood, beta? So all the strong field near the poles, correct, Vendan? And inside the magnet, the lines will be, the magnetic field lines, the closed loops will be parallel. They will never touch each other. So strength of magnet is uniform inside the magnet. So magnetic field strength is uniform inside. I hope you people have understood this part. Correct now? Because all the lines are parallel and in equal distance with each other. Got it? So it is uniform inside. The magnetic field will be uniform inside. Till here it is clear? Crystal clear that okay, this part is understandable in magnet. Now better the next part. One by one, we will disclose all the concepts of magnet first. Understood? Now, the magnetic field lines are closed loops and they will never intersect each other. Why? The magnetic field lines will never intersect each other. If one magnetic field line is there, another magnetic field line will come and intersect like this. What will happen? The correct point is, Namasvi, you are there? Yashvit? See, look here, beta. Every loop will be having points in it. Since there is a direction in magnetic field lines, the magnetic field lines are having direction. It is coming out from North Pole, going towards South Pole. Understood? So, coming out from where? North Pole and going towards South Pole. So, they will never intersect. This is what I am going to teach. So now look here. So this point, beta, you understand this. So if it will intersect, what will happen? So when it is not intersecting, what is happening? And when it is intersecting, what is happening? So this is the one which is not intersecting. Correct now? So that means every point is directional. If you will see, it will show one specific direction. North towards south. So every field line will exactly show one tangential path, and this tangential path will drive the magnet to go from North Pole towards South Pole. Correct na? North Pole towards South Pole. That means each point on the loop will be showing a direction to go towards North Pole to South Pole. But here, when they will intersect, so this one is showing this direction, this one is showing this direction. So when the two loops are exactly intersecting each other, the point of intersection will show two different direction, and one tangent line cannot have two different direction. One point does not show two tangential directions. Understood not? So here one common contact point is there and it is showing two different direction. Is it possible? No. So magnetic field lines never intersect each other. Did you got this point crystal clear? So magnetic field lines, are they intersecting each other? Never. The magnetic field lines never intersect each other. This is a very important point to remember. I hope everybody got this point. Yes, absolutely correct, Vendan, Ilavarsan. So only, so whenever they will ask, you will say that a direction, the tangent line Yes, I'm going to explain it one more time. That explanation, those people who are having problem in explanation, please kindly understand the magnet is having magnetic field. Correct now? The magnetic field is due to these loops. So these are magnetic field lines, magnetic field lines. Understood not? Magnetic lines of forces. So these loops are generating this magnetic field. Correct now? So that means they have some energies and that only is generating a field around. Correct? So that means every point is showing some direction. A circle, tangents can be drawn only one. Na? From a circle, the direction will be shown. Every single point will show one direction. Correct na? Like this. And this direction indication of every point on the loop will drag the lines of forces from north pole towards south pole. Are you understanding this one? Correct. But what will happen if two lines of forces will intersect each other? When two lines of forces will intersect each other. So when two lines of forces will intersect each other, there will be a point of intersection. In this point of intersection, the tangent line, because this line is moving towards this direction, and for this one, it will go towards this direction. So two different direction indication came now for one single point, because it is the intersecting point of two loops. So, but we know that only one tangent is drawn at one point. Only one tangent we are drawing to one contact point. It should not go two, it should not give two different directions. So this contradicts our thesis, our understanding that only one point will give you on a circle, only one directional point will be given by a tangent line. I hope you might have understood. In a circle, when you are drawing tangent, you are not drawing multiple tangent from one point. You are drawing only one tangent. So here, this is exactly curve. Curve can also have one point will have only one tangent, na? But here one point is having how many tangents? Two tangents because of two intersecting points. So when two tangent drawn means it contradicts our mathematical concept. So magnetic field lines never intersect each other. Did you got this point now? Yes, yes. So I hope everybody understood that the magnetic field lines never intersect each other. Understood? Two tangents are drawn and these two tangents will contradict the hypothesis, this section. So this is not true. So 100% this point is going to violate the other rules of magnetism and mathematical concepts also. So here we are going to understand the next concept. So I hope you people have understood this one. Please read thoroughly. For science paper, reading thorough is very important. Understood? So magnetic field lines are closest at the pole. We understood. Their strength is maximum near the poles. They have a uniform strength inside the magnet. That also we saw. Next, if no two magnetic field line intersect each other, for that what point we have given? The direction of a magnetic field at a point is indicated by tangent at that point. This is the concept which will get violated if they will have two directions. Correct now? Because see, read this part, Yashwet. The direction of a magnetic field at a point is indicated by tangent at that point. At the point is indicated by tangent at that point. That's the most important. Okay. So natural magnet. Which one is natural magnet? Magnetite or lodestone, Fe3O4. Remember, the black ore of iron is a naturally existing magnet. Note down, magnetite or lodestone. We do not expect any type. See, right now, every single point in every chapter is important. We cannot exclude one single point also. So you have to write everything. Everything is important for us. So what is the magnetite or lodestone? That is the black ore of iron is naturally existing magnet beta. Remember this one. So magnetite or lodestone, the black ore of iron is a naturally existing magnet. Okay. Now Oersted experiment. See, from Oersted experiment, based on Oersted experiment, questions came many times. Please remember, question came many times based on Oersted experiment. So this experiment is very, very important for us, and one idiot is missing. Call Ray. Call him. He went to drink water. He went to make water. Yes, direction of compass beta, and see, related to direction, they're asking one question, Maha, what mistakes are there? This is the time to overcome that one. So small part, Maha, this time one single question also we need not to two donkeys are. So this time one single questions are important for us, and beta one question at least 2 to 3 times analyze and finish. Okay, so that in exam it should not skip from your brain. We have very less time for science. We have to do more in science. Now beta Oersted's experiment. What is the Oersted experiment? See, accidentally one compass kept near a electric field. Electric field means beta a wire carrying current. Understood? So this wire carrying current will generate an electric field. Understood? So this electric field, near this electric field, if a compass is kept, the compass is exactly started showing deflection. The deflection of the compass is indicating a very important point. And what is the indication of this? Hello? Yes? Yes, I'm speaking now. Please kindly say. Ma'am, can ma'am, please drop the resume in WhatsApp group in this number only. Subject? Okay, ma'am. Okay, I'm in live class right now. So look here. So when somebody will be asking you about this Oersted's experiment, what is exactly? The needle is deflected, which means that electric current through the copper wire has produced a magnetic effect. Understood? So this what closed circuit, when current started moving, made a electrical field. Understood? So this electrical field has deflected a magnetic compass. What does this indicate? This indicates that there is a magnetic field around an electrical circuit. Understood not? So when a circuit is carrying current, it generates a magnetic field perpendicular to the circuit. Understood not? So now we have to see the direction. Here, what is the most important point is direction. We have to be accountable with direction. Understood? So now the needle is deflected, which means that the electric current through the copper wire has produced a magnetic effect. So the north and south direction deflection must be seen. So this means we can say that electricity and magnetism are linked to each other, correct? So direction, already we have done Oersted's direction. We will study it one more time. Okay, are you all ready? Correct? Now, magnet in a magnetic field. So whenever we talk about a magnet in a magnetic field, then magnet will be experiencing two type of forces. One is attractive force, one is repulsive force. But a attractive force, when it will be coming, when north and south will be there. Understood not? Because they will align each other and join together to make another magnet of higher intensity. I hope you might have understood. So one magnet aligned with another magnet like this is not possible. They will repel. But one magnet aligned like this, now this magnet will have a stronger magnetic field. Understood? So magnet alignment is most important. Understood? On the surface of the earth, a magnetic field exists due to content of earth. Understood? Making it behave like a magnet. So that part we are going to discuss in very short. We are taking the classes because more is there in the live classes. We have already done that. Okay, let's see one paper I need. I wanted that oyster part. Yes. This one I was wishing to go with. The direction of deflection also change if you reverse the direction. This oystered part is important. Practical learning is important for us because from there one question they may ask. Okay, so we will be doing this very nicely, where we are going to keep compass and where we are going to experience the deflection. So practical learning about oysters experiment. Understood? So produces an electric current, produces a magnetic field. Understood? So now a magnet is not only the thing that produce a magnetic field. An electric current is also producing a magnetic field. And who has given this concept? In 1820, it was given by Oyster. Understood? So the magnetic effect of electric current can be very easily be demonstrated by bringing a magnetic compass near a current carrying wire. A compass needle gets deflected, showing that a magnetic field is produced near the wire. So magnetic field produced near a wire means what? Practical learning. Are we ready for it? So for practical learning, just take a magnetic compass on a wooden or plastic block. Okay, I'm just reading it out for you people. You also read. When the compass needle comes to the rest, fix a wire over a compass. So just see what is the procedure, because many times they are writing the procedure and you need to go with the procedure. So just reading the procedure out so that we should not skip any concept there. Oystered part is important. First, place a magnetic compass over a wooden or plastic block. What type of block? Wooden or plastic block. Near that we are putting one compass. Away from all magnetic material. There should be no magnetic material which can influence the compass. Next, when the compass needle comes to rest, fix a wire over the compass. Are you understanding? So we have given more priority to compass. Parallel to the needle. Correct now? So connect the wire to a battery through a switch as shown. We are going to see the figure. Close the switch to pass the current. Now this much I think it is enough for you. Correct now? So if the direction of current is from south to north, here we have to see what they are speaking. We need to check this point. Please check this one out. The compass needle will show deflection and comes to rest at right angle. So what is the conclusion? See, close the switch to pass a current through the wire. What is the observation? The compass needle will show deflected and come to rest at right angle to the original position. If the direction of the current is from south to north, what is the direction of the current? South to north. Correct? Then the north pole of the needle will comes to rest pointing towards west. So the north pole of the needle will move towards west. Correct? Now hold the compass above the wire. The needle will get the deflection to opposite direction. So that means here or here, where the compass should be is also very important thing. Are you understanding? The placement of the compass is exactly north to south and south to north. Yashvit, I'm going to explain. So look here. So that means the location of compass also plays a very vital role. So let's see this one out. Now we are ready for seeing this part. Let's check this one, beta. And after that, what they are telling, the direction of deflection will reverse. If we will reverse the direction of current. Now, for short period of time also, you will be seeing this deflection will come. Now check this one out. So once the current is moving, can we check this part? Because direction will reverse out. So one thing is very important for us. Can we check this one out, beta? What is the direction of movement of current? This is the direction of current. It is coming from north to south. Understood? So it is coming from north to south. Compass is kept here. It is deflected towards east. It was north compass. Now it's deflected towards east. So now if The current will move from south to north. The compass needle will deflect towards west. Now note down, draw it. Huh? Yes, it will deflect. It will start deflecting towards east. Understood? It will start deflecting towards east. Good evening, beta. Just do this. Draw these two parts, please. North to south, south to north. South to north towards west, north to south towards east. Are you understanding it? But this experiment should be done for a long period of time. No, for a short period of time, because it will drain the battery and then also the magnetic field lines will stop. Okay, so here this experiment for few seconds only we are doing, and we are experiencing the deflection of the needle. I hope everybody understood this one. Now I think, Yashwit, did you got this point? This drawing is enough to explain the part now. So outside the field, if we are keeping, the direction of current is from north to south, it will head towards east. South to north, it will head towards west. Just this much only remember. Understood? North to south, current. North to south, it will move towards east. South to north, it will head towards west. This is. Understood? North to south, E. NS, E, SN, W. NSE, SN, W. Remember. So this is the thing, Oyster, and I was really wanting you people to remember this, remember this, remember this. Okay? Because if any question related to this will come, we must know. Now, magnetic field of a current carrying conductor. Now, we will check about the magnetic field of a current carrying conductor. So now Oersted experiment performed an experiment to show that magnetic field is set up around a current carrying conductor. The experiment was performed as follow. Electric current was allowed. This already we know that. Now the parallel to the axis. Now what electric current was allowed to flow through a metallic wire placed parallel to the axis of a magnetic compass kept directly below the wire. We have kept it below that part. The needle of the magnet compass was found to deflect in its normal position. So this deflection we have experienced. Understood or not? Now, beta, just check this one out. What we have learned right now, same it is showing now. Can you check what is the direction of flow of current? South to north. It is heading towards west. Understood? So on it, if I am keeping the compass, it is heading towards where? West. Now, north to south. See, the current is moving from north to south. It is heading towards east. I hope is it crystal clear now? Is it crystal clear that yes, ma'am, it is understandable and we can do it. North to south. North to south. It is going north to south. It is east. South to north. West. That you need to, and then we have understood about this swimming rule also. So direction of deflection of the needle of the magnetic compass, that is direction of needle compass due to electric current passing through, that will be also considered by the swimming rule. Understood? So swimming rule will be exactly a same rule is there here. North to south. You see, consider a man swimming along the direction of current in the wire. If this is exactly direction of current, it is swimming towards this, towards north. So the electric current, the feet, the leaves hand. So the north of the needle of the magnetic compass will be deflected towards its left hand. It will go towards south. No, it will go towards east and west. So that is exactly the swimming rule. So remember, Ampere's swimming rule is also known as snow rule. Got it? So Ampere's swimming rule is there in NCERT book. I think it's not there. So magnetic field due to current through a straight conductor. So now I'm going to go specifically to that part. It's not there. Swimming rule is not there. Oyster is there. Yes, oyster rule is there, that I know. Right hand thumb rule, I don't. Sorry, right hand thumb rule is there. Swimming rule, ampere swimming rule is not there. Yes, I know that. So, nah? Hmm. So, but I think oyster rule you understood or not? North to south, east, south to north. You don't noted, na? So now look here. NSE. Always remember. SNW. Snow you wrote na. SNW. Snow. You remember snow. That's what it is called, a snow rule. Did you understood snow rule? SNOW. South to north, west. Then north to south, NSE. Snow, you remember? South to north, magnet will head towards W, west. NSE, Nestle. Nestle, you remember na? NSE. Nestle spelling you remember, you will be able to do. So magnetic field due to a current through a straight conductor. So now let's talk about the magnetic practical learning means we will be, I'll just explain this part. So observation and all is that much is not important, but we will be understanding this section by the drawing. Understood or not? So I hope everybody remember this section. So now I'm just going to talk about the magnetic field lines. Okay. So magnetic field lines, one section I think in NCERT it is there that I need to discuss. I missed that part. Magnetic field lines. Magnetic field lines we discussed. Nature of magnetic field lines we have discussed, beta. Bar magnet part we have discussed. Okay, magnetic field of Earth, that was not discussed by me. So magnetic field of Earth, that is very, very important. One time I'm just discussing that part. I should not leave because in this it is there or not, don't know. So we will check this part. So beta, you need to understand that our Earth itself is having a magnetic field. Okay, it is because of the magma that is present inside. Understood? So our Earth magnet is not like this. It is little bit tilted. Understood? But the geographical north is exactly the south part of magnet. Understood? And the geographical south is having north part of magnet. So only our compass will always direct towards north because of north-south love. Are you understanding? A simple technique I am explaining you. Everybody, please remember this part. Okay. So what I am explaining right now, please kindly understand. What did I said right now? This is the Earth is geographical north. This is Earth geographical south. So our magnet, Earth magnet, will have what direction here? It will have south and it will have north here. Understood? Because of this, any compass you will keep, na, the compass will have north deflection here to our geographical north. But it is having showing love for whom? Our Earth magnetic south pole. Yes, inside the Earth, the magnet is present. It is having south pole on north. South pole on north and north pole on south. Are you understanding? But beta, the angle also is not same. So if this is geographical north and geographical south, then our Earth magnet will be quite tilted, making some angle. So this is south and this part will become north. So it is exactly tilted and it is making some angles. I hope you might have understood. See, the angle shift will come after every 100 years. Understood? So this magnetic, whatever angle it is subtending, this angle shift will be coming after every interval of time. Understood? But it is not like this. It is slightly making some angle. And that time now, when it is shifting angle, that time now the cosmic waves from the space is entering. And that's what the skin cancer or something is happening now. That's exactly the reason behind it. I hope you might have understood that one. So that lapse will come. That lapse will come, and in between they will change the direction, but it's a very short interval. Got it? But the angle will shift. So this is exactly one of the characteristics. So our earth magnet, that topic only I left, so I just discussed. So our earth magnetic field, beta, what direction it is there? Our earth magnet, south pole is in geographical north and north pole is in geographical south, and so only our compass ideally directing towards north. It is not because of geographical north, it is because of south pole of magnet of earth. Understood? Now is it crystal clear, children? The intensity of magnetic field of earth is very high. Every planet, if it will be having the intensity, they will never allow the cosmic waves to enter inside the earth. Understood? It's like the cosmic waves that is present in the space, the magnetic field of a planet does not allow the cosmic waves to enter inside because they reflect in different directions. Understood? So this, the moment the belt will receive, the shift will be there from the magnet, that time the lines of forces will change. Understood? The moment this magnetic field lines will change a little bit with certain angles. Right now 11 degrees some is there. Maximum tilt is 11 degree. So 9 to 11 degree only it is shifting. But the little bit shift will come. At that time, the magnetic lines of force will change the direction. The moment it will change the direction, little space it will generate. The cosmic waves from the space will enter inside the earth. Understood? The deadly waves will enter inside the earth. Understood or not? And that time what will happen? It will exactly create more havoc. I hope you might have understood. So magnetic field lines are actually very big savior for any planet. Huh? Yashwit, understood this? So higher order of thinking based on informations, we are going to discuss that part. But first, we are going to magnetic effect, electromagnetic content, we are going to understand that. So one experiment I am going to do and show it to you, the direction. So please understand this part, where and all are the directions. So one cardboard I am going to take. In that cardboard, I will allow one, I'll make one hole, and from this hole, one wire I will connect. Correct? Now it will have current. Understood or not? Now what will happen? So once I will allow the magnetic lines of forces, now the current is exactly moving from this direction towards up. Correct? Now what is the direction, beta? From south to north. Understood? So magnetic lines of force will move clockwise or anti-clockwise. This has to be seen. So around this, magnetic lines of force will be generated. This magnetic lines of force will be circular. Understood? The intensity will keep on increasing. Yes, and very good. It will be exactly which direction? Anti-clockwise. Yes. So it will come as anti-clockwise. Can you check like this? This is called as what, beta? Anti-clockwise movement. Is it clear right now? Huh? Is it clear right now? This is coming as anti-clockwise. So we are going to write S, N, anti. NS, clock. Understood? Simple tricks. We are not going to read that much. SN, anti-clockwise. When it is going from south to north direction, it will go anti-clockwise. That comes under the right hand thumb rule. I hope corkscrew rule also, Maxwell corkscrew rule also is exactly the same rule. When it will be, so the Maxwell corkscrew rule and right hand thumb rule, it will be exactly showing this only. Can you see the hand will go towards you, means it will be anti-clockwise. It will be what direction, beta? Anti-clockwise. Now from south to north, it is coming anti-clockwise. North to south, clockwise. Understood? North to south, the direction will be exactly coming as clockwise. Is it understandable, children? You understood it very nicely. So this is one rule, beta. Now next one. So here some questions will be asked. Here some questions I'm going to ask from you all. Okay, so this is north and south, so we understood. The direction of magnetic lines of forces also understood. Beta, how can we generate a more impactful magnetic lines of force here? Right now, the lines of forces are having this lines, dismus lines. Can I make a more stronger magnetic field here? For making a more stronger magnetic field around this wire, what I am needing? Correct. So that means what? If it totally depends, the magnetic field strength around an electrical wire totally depends upon few factors. The first factor what we are learning here is कि when I want a more magnetic field around a wire, I have to increase the amount of current. Understood? So if I will increase, understood? So if I will increase of current will increase the magnetic field lines. So increase of current will increase the magnetic field lines, and that will be increasing the intensity of magnetic field. Is it clear? Is it crystal clear? It will increase the intensity of magnetic field. Now, another important point, this is exactly for one straight wire. What if I am going to take a closed loop like this? Now you tell, okay, if the current will be moving from this side to this side, now what will be the magnetic lines of forces? The magnetic lines of forces generated will be again circular. Is it okay? Understood? So what it will become, beta? This is the information. At the center of circular loop, all the magnetic lines are becoming same direction and aid each other, due to which the strength of magnetic field will increase at the center. So here what will happen to the strength of magnetic field? What will be the strength of magnetic field here? Strength of magnetic field at center. This is a very important question. Please kindly draw and remember that what will be the strength at the center of this, so the magnetic field lines will become straight. Understood? फिर सेट कर दी बेटा, सब अच्छा होगा। साइंस का पता नहीं, इसीलिए साइंस में थोड़ा एक्स्ट्रा प्रिकॉशन लेके चलो, ज़्यादा से ज़्यादा पढ़ लो, वही कर सकते हैं हम और कुछ नहीं कर सकते। जितना हो सकता है बेसिक से लेकर के कोई भी लेवल को छोड़ो मत, करते चले जाना है, स्टॉप नहीं होना है ना। लुक है बेटा, अंडरस्टैंड दिस वन नाइसली। सो इसलिए छोटे छोटे डिटेल्स को बिना इग्नोर मत करना, कौन कहाँ पे गिरा के दे देगा कुछ पता नहीं। चलो लुक है बेटा, सो एट द सेंटर सी, लुक है, व्हाट इज द डायरेक्शन बेटा? South to north. It will go which direction? Anti-clockwise. Understood? And this is going from north to south. It will go clockwise. What beta? And beta, in center what will happen? It will add up together as one. So magnetic field line strength will be maximum at the center. So only I wrote strength of magnetic field at center will be more, maximum or more, what you can say. Understood? So note down this part. These things are something, one will be north to south and next one will be south to north. At the center it is exactly strengthening. The strength of magnetic field will be maximum in the center. Strength of magnetic field at the center is more. Understood? Because the lines are add up together. The lines add up. Magnetic field lines are add up together. Add up. Understood? Means added up together. So the strength of magnetic field lines will be maximum. The strength of magnetic fielding will be strong near the loop, right? It will be strong near the loop and it will be strong here also, now, because the directions are exactly merging together. Namasvi, sorry, Yashwit, remember this one. Understood not? See, though the lines of forces are concentric here, but here what will happen? The lines are adding up together. So only the lines where the merging line will be there, here also the strength will be maximum. Remember this part. So its strength of magnetic field will increase. So if we will increase the current, then what will happen? The loops will become more closer and the intensity here will increase more. I hope this is clear, beta. Understood. So here magnetic field intensity is more because the lines are exactly coming from here. Na? So strength of magnetic field is high here. Strength of magnetic field is high here. Strength of magnetic field is high here. I rest my case. 3 points is exactly important here. Did you got this point, beta? So now we are going to understand what and all magnetic field lines dependent upon. So magnetic field lines are directly proportional to the current. Understood? So the strength of magnetic field line is directly proportional. Write down, beta. So we can write the magnitude of magnetic field produced the magnitude of magnetic field produced by a current carrying loop by a current carrying loop, note on data, by a current carrying loop at its center is note down directly proportional to the current passing through the circular loop. Second one is inversely proportional to the radius of the circular loop. Understood. So the more we will go away, the more magnetic field strength will reduce. But beta, here this point, the field will increase because the lines are adding up. Understood? Beta, how was the maths exam? So this is what? This is the most important thing. Now, two things we learned. So see, how much current will flow in the wire, that much will happen what? Magnetic lines, strength of magnetic field lines will be more, correct now? Another thing is, when they will be joining together the one direction, see this is going anti-clockwise and this is going clockwise, but one point will be there, they will merge. So here magnetic field strength will be maximum. थैंक यू सो मच बेटा. कैसा गया एग्जाम तुम लोगों का? डिफिकल्ट था? थोड़ा तो था बेटा, ये तो जानते हैं. ऐसे कैसे हो सकता? हाँ, क्या सकते हैं? No, question will be same throughout country. लेंदी था, यस, ये कह सकते हैं. Case of solenoid I am going to discuss. This is only one loop beta. When loop will add up together, that time we will be discussing. Just now one part only we have discussed. We didn't discuss about the strength of magnetic field can be increased by circular loop beta. So this is exactly one part was there. इंग्लिश का है नेक्स्ट. इंग्लिश भी कर लोगे यार, कुछ नहीं है, तुम लोग कर सकते हो. नथिंग इज इम्पॉसिबल. अच्छे से पढ़ेगा तो हो जाएगा. हाँ, बट बेटा मैथ्स का कंप्लीट कर, मैथ्स के बाद का थोड़ा सा डर लग गया, तो रात में भी पढ़ाना है. हाँ, आफ्टर मैथ्स इंग्लिश है ना तुम लोगों का, मगर इंग्लिश के बीच में जो गैप है ना, उस गैप में सोलेनॉइड में कैसे होगा अभी मैं एक्सप्लेन करने जा रही हूँ. सोलेनॉइड बेटा क्लॉक फेज रूल भी अभी एक्सप्लेन करूंगी, सोलेनॉइड भी एक्सप्लेन करूंगी. सो दैट मीन्स व्हाट बेटा, द मोर द रेडियस विल इंक्रीज, द मोर द मैग्नेटिक फील्ड स्ट्रेंथ विल रिड्यूस. अंडरस्टूड नॉट? सो दिस इज वन पार्ट वी हैव डिस्कस्ड. नाउ वी आर गोइंग टू टॉक अबाउट द क्लॉक फेज रूल. बिकॉज सोलेनॉइड में क्या होता है कि व्हेन यू विल बी टेकिंग सर्कुलर लूप्स, ओके Kritika, how would the strength of magnet due to the current loop be affected if the radius of the loop is reduced to half of its original value? Ma'am, please explain. So this is a very good question. So now look here, beta, understand this. कि when you will reduce the radius of the circular loop, understood? So then the magnetic field strength will increase. That's what it will double it. Yes, beta, offline भी पढ़ाते हैं. आप कहाँ से हो? Understood or not? So she just asked one question. It will just because inversely proportional, it will become half, then this will become double. ओके, फेरिक एंड फेरस के बारे में पूछ रहे हो, करेक्ट ना? ये तुम्हारा एलिमेंट पे डिपेंड करेगा, एलिमेंट के वैलेंसी पे डिपेंड करेगा. ओके, एलिमेंट के वैलेंसी पे डिपेंड करेगा बेटा. एज आई एम अ मैथमेटिशियन, बट ओके. So now shall we start beta clock phase rule, or I think I will switch off the this session. It is already increased to 1/7. After that again I am starting. Okay, just now itself I am going to start and I am going to discuss solenoid. 1 hour 7 minutes over now. So again I am going to start. Already बेटा मैंने यूएस के बच्चे को पढ़ाया है. Yes. Yes, already कुछ बच्चों को. Time is right now 7:56. Okay, you go.